Hello, and welcome to 5-Minute Math. Today we are looking at the 5th grade concept of identifying prime and composite numbers. This is standard 5.4a in the great state of Texas, and we are using item number 13 of the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we have a list of numbers, and 51 to 55. How many are composite? Well, we need to know the difference between prime and composite. Then we need to have some strategies to figure them out, especially if they're larger numbers like this. So prime numbers only have two factors. The only way to multiply to make a prime number is going to be 1 and itself. Right, so the number 3 is a prime number because the only way to multiply anything to get to 3 is 1 times 3. Composite numbers have 3 or more. So you can have 3, you can have 4, you can have 87. 3 or more factors. And that's really the difference. So let's just take a look at each of our numbers individually. Okay, so 51. And really what I'm looking at is I am looking at some of our basic numbers that I want to divide by. I want to see if I can divide by 2, by 3. I don't need to divide by 4, because if I can divide by 2, I can divide by 4. I want to divide by 5. I don't need to divide by 6, because if I can divide by 6, that means I can divide by 2 and 3. And maybe 7, and then sometimes you need to get up to 11. That's about what I need to get to. And these, are the list of the first 5 prime numbers. And so that's really why I'm looking at them. I want to see if I can divide by them. So 51 is not going to be divisible by 2 because it's not even. I don't know about 3. There is a divisibility rule that we can use here. If you take the digits in the number and add them up, so 5 plus 1 equals 6. If this can be divided by 3, so can this. So 5 plus 1 makes 6. That means 3 times something is going to make 51. Okay, so 3 times, we can just divide in here, 3, that's going to be, oh, look at that, 21, so 17, 3 times 17, right? And then we obviously have, and I got them out of order here, but we've got our 1 and our 51. We can always multiply 1 by itself here. So let's flip those. And let's see, can't be divided by 5 because the ending digit is not 5 or 0. By 7s go up to 49, and then 56, they skip that, and it's not an 11. So this is composite. I'm going to put a C there because it can be divided by 3. 52, definitely composite, just simply because it's even, right? 1 and 52, it's going to be 2 and 26. And honestly, we could do a 4, or we could do a 13. I think that might be it for us. A standard deck of cards has got 52 cards, 4 suits. Each suit has 13 cards. So that's also composite. So 53. It's not going to be divisible by 2 because it's odd. Let's check the 3. 5 plus 3 equals 8. So no, not divisible by 5 because it doesn't end in a 5 or 0. 7s, right? 7 times 7 is 49. 7 times 8 is 56. So we miss that. Then 11s needs to be a 55. So if we want, we could extend to 13, right? So we've got, obviously the 13 goes to 52. So that's not going to work. So this is a prime number. Let's put a circle around that. 54. Nope, because it is even. So 54, right? We've got 2, and what's that going to be? 27. 5 plus 4 equals 9, which means it's also divisible by 3. So 3, this is 3 times 17. This is going to be 3 times 18 because 54 is 3 more than 51. Can it be divided by 4? No, it can't. Not by 5, 6, 7. It's not going to get there. We can do 9, right? So 6 times 9. And that might be it. And then we've got 55. This is definitely not going to be prime because we've got 5 times 11. So that's also composite. So I've got 1, 2, 3, 4 composite numbers. The answer is A.